Hey guys, welcome back to CodeStorm. In this video, we will learn about records in Java. Java records were introduced to make writing data-centric classes quicker and easier. Traditional classes often involve boilerplate code. Consider this example where I've created these three variables to hold the data. We need to create an empty constructor, all arguments constructor, getters and setters, equals and hashCode, and finally toString. Just to hold the data of these three variables, we are writing around 60 plus lines of code. This is the main reason why records will help us. Think of a record as a simplified version of a Java class designed to hold data. It's like a blueprint for creating objects that primarily store information. We need to consider the following things when we are using records. Record is final. We cannot extend with some other class or not even object. Let's test this. As you can see, we will get the error. No extends clause allowed for a record. Because, as I said, record itself is a final. And the second thing which we need to consider is all the variables which we have defined here are final as well. As it is final, they are immutable. So once we set the value, we cannot update the value for the same. In record, Java itself creates the constructor, getters, equals and hashCode, and toString for a record. It won't create setters. As I said, all the variables here are final and immutable. Now let's compare on how easy it is to initialize the values with less number of boilerplate codes. Here it's just a single line, but in a traditional way, as you can see, we need more boilerplate codes. This is a test class where this is of a traditional class and this is of a record. As you can see, the initialization of both the class and a record are same to same. Now let's print the values. As you can see in the output, both the class and the record behave similar. The only difference is record uses less code and class there are plenty of boilerplate codes. As we have compared the class and the record, you might be wondering how to access individual parameters here. It's simple. Now let's print description system.out.println post record dot description. There is no setter for this, and this is posted date time. All the variables inside the record are immutable. So once it is assigned, we cannot change it. Let's say if I try to do 2L, this will throw the error. So updating the value of already assigned record, as it is immutable, we cannot do that. Now let's run this output. For this three print statements, these three are the values which we get. So if we want to fetch a value of a particular parameter, we can achieve by using record.description, record.id, record.postedDateTime. In records, there are three different types of constructors which we can use. One is non-canonical, the second one is canonical, and the third one is compact. Non-canonical constructors can have different parameters or a different number of parameters. In this example, I'm considering different number of parameters where here I'm accepting only two values or two variables, but in the root constructor, we are having around three variables. There might be a scenario where you would be needing only two variables instead of all the variables, so you can use non-canonical at that particular place. So finally, you can set the third variable, which we have not added in this non-canonical constructor, either as a null or any predefined value. And the second constructor is canonical. These are the primary constructor that is implicitly defined by a record. You might be thinking, as it is already defined, why am I using the same here? Because I wanted to do this additional check where I wanted to validate whether the ID is greater than 1. The predefined constructor of a record would look something like this. The third way is compact. And before going to compact, you might see there is a warning over here. Convert canonical constructor to compact form. Here, compact form is our third type of constructor, which I have written here. Before going to compact, let's test the output for these two constructors. Here, postRecord plus 1 is a non-canonical constructor where I am passing only two variables instead of three. And now, postRecord plus 2 is a canonical constructor, which is a defined constructor for a record. Now let's run this test. In the non-canonical constructor, even though I have not passed the local date time or a posted date time, it is taking the value from our non-canonical constructor where I pass the value as local date time dot now. And when coming to the second one, where it is a canonical, it's just a normal behavior of a record or a implicitly defined behavior of the record. Now let's validate whether we get this exception or not. I'll set the value to 0. Finally, we got the output. This is non-canonical, which works as expected, but in this canonical form, where I've set the value to 0, it gives the exception as expected. So where ID should be greater than 0, which is the error which I've set over here. Now let's jump into the third kind of constructor, that is compact constructor. Instead of converting this canonical to constructor, I'm just commenting this out because I've already created a compact constructor over here. As you can see, the difference between canonical and compact constructors are there is no need to define the variables again here because it accepts the same number of parameters as in the root constructor. And I'm performing two validations and one transformation over here inside a compact constructor where I'm checking ID is lesser than or equal to 0. If yes, then it will throw the exception. And I'm validating if description is blank. If it is blank, it will throw the exception. And finally, I'm transforming the description to its lowercase. This is just a practical example to show that we can perform the validation or transformation kind of operations inside a compact constructor. And if you notice, there is no need to use this dot description in compact. Let's see the error which we get. It says cannot assign a value to a final variable description. When we use compact constructors, there is no need to use this. We can directly use description is equal to description to lowercase or any other operation which you want to perform. Now let's run the output for compact constructor. This is the same test method where earlier this line was for non-canonical and this one was for canonical. But now as I have commented the canonical part, this will point us to compact. This will point us to compact. Now let's check when the description is blank whether we get this exception or not. I will comment this out as we have already seen how the output for non-canonical looks. As expected, we get the description should not be blank exception. Now let's see how the actual response of this compact constructor looks like, where I'm transforming description to lowercase. We got the output, and as you notice, the description is in lowercase as expected. There is no need to use the constructor explicitly inside a record if you don't want to change any behavior of the existing variables. But if there are scenarios where you need to use lesser number of variables or different types of variables in a constructor, then go for non-canonical. If you want to perform validation or transformation for the variables, you can use compact. Canonical is not preferred way, compact are the preferred way. If you remember, I earlier said we cannot extend, but we can implement the interface in record. Now let's see how it works. Let's consider this interface where it is just a void print value method, and I've created a record where I'm implementing the custom printer and overriding this default method, that is print value of a interface. And inside that, I'm printing this value which we pass through our record printer. I repeat, in record, we cannot extend some other class or not even an object, but we can implement the interface as I have shown here. Now let's run this output in our test class. This is a test method where record printer is a record which implements the interface, and I am passing the value and I'm calling this implemented method, that is print value, which will print a statement. And the output is here printing the value and records. I am passing the records, the value from here, and I'm printing the statement inside the implemented interface. This is just a small example of what you can achieve by implementing interface. We can do much more operations through this. We can also use records inside a particular method. Before using the records inside a particular method, let's understand what this current code block is doing. This is just a map which holds a string and the value. So here I'm converting this map into a stream. I'm mapping each value to this particular string, and finally I'm printing each value. Let's see how the output for this looks. Finally, we got the output. This is the key and this is the value, and the output is as expected. Now let's see how we can achieve this by using record. So here operation is the record and it's accepting two variables. One is string and one more is the integer. I'm overriding the toString method of a record class, and I'm formatting the string as required, where %s is the key and %t will be the time. Key as repeated value times. Here, instead of this earlier approach where I was using this m.getKey and adding a string in between and again printing the value and finally adding a string, we can use this record to make it even more simpler by just calling inside a map. When we call this operation record and pass the string key and the integer value, it will convert into the format which we have written here. This is just a simple example on how to use a record inside a particular method. We can do more complex things or even use it as a tuples as I have shown here. And this is how the output looks when we use the records.